Hello all, welcome back to AK App Logics. In the previous class, I have discussed about the push button in active high with the pull down resistor. So let me extend put the push button with active low uh, push button in active low with the pull up resistor and as well as push button in active high with pull down resistor. Let me extend both of these previously discussed circuitaries or the configurations of the push button to the uh, extent some level. To the extent I will extend this particular circuits to some little bit more level. So what we have to this is the pull active low with pull up resistor configuration which I have discussed in the previous class. You can see over here, this is the code, this is the same code, and this is the circuitry. So what I'm going to do is, so whenever this particular, you have to watch first that video, then only you can able to understand this particular video, otherwise you don't understand that particular video. So you go to the playlist available in my channel and watch that particular video, which is the push button in active low with pull up resistor. So then after completing that particular video, you come to this particular video. This video will be very short. So this is the code that we have discussed in the previous class, and this is the circuitry that we have discussed in the previous class. Now what I am going to do is, whenever the button state is low, that is the input that is getting from the push button to the Arduino is low, then I am going to take an LED and make it low. Okay, whenever this condition came, I'm going to take an LED and make it low, and whenever button state is high, I'm going to make same LED high. Okay, for that, firstly I will make the circuitry. You can see over here. So I'm taking a resistor of 330 ohms because to connect LED we need a 330 ohms resistor. That thing also I have discussed in the previous first video. Guys, you guys also watch that particular video, then only you can able to understand. So let me take an uh, yeah, so let me take an LED. So I have taken the LED, I have connected both the resistance and LED. I have connected cathode of the LED to the resistor one end, and I have left anode over here. I'm going to give anode to one particular pin, that is pin number uh, let me show you. So I'm going to connect, so wait a second. So I'm going to connect ground to the minus, this particular terminal minus. So I'm going to connect ground to it. So see, so I'm connected the ground to this minus, and from that minus, this particular line, I have taken one wire and connected to the resistor another end. So in the first video I have discussed about the breadboard, right? This particular horizontal dots are shorted in case of plus and minus, whereas in the case of A B C D E F G H I, these five vertical dots are connected like this. Okay, like this, these points are connected. Similarly, upper A B C D 5 dots are connected vertically. So if you want to have a more clarity on the breadboard, how does it work, or how it going to work, you just watch the first video. Okay, then you can able to know how that breadboard is going to work. So I have made the connections, and I'm going to give resistor anode to the pin number 12. Okay, yeah, I've connected pin number 12 to the anode of the uh, LED. So I have made the connections. Okay, I have connected a resistor 1 and to the cathode of the LED, and another terminal, that is anode of the LED, to the pin number 12, and I have connected resistor another end to the ground terminal. So let us see the code, what are the modification I have done. So I have to declare the pin, which is the output pin, that is 12, right? We have to give the output based on the push button. If we receive the low from the push button to the pin number 9, then we are going to send output low to the LED via pin number 12. If we receive the high from the from the push button via pin number 9 to the Arduino, we are going to send the high to the pin LED terminal anode via pin number 12. This is the basic operation. Okay, so I am, for that I am going to declare the LED pin, that is SN to the 12. Okay, so I have to declare this particular pin as an pin mode, this particular pin as an output using the pin mode. So I am going to use pin mode LED comma output in the setup function, which is executed only once after providing power to the Arduino. So next, in the loop, I have to declare in the if condition else condition. I have to make, in if condition, if the button state is low, I have to make the LED low, right? For that I am going to use the digitalWrite operation. So digitalWrite LED comma low. Whereas in the case of else, I have to make digitalWrite LED high. Okay, yeah, simple. This is the code. This is the code. Yeah, this is the code, guys. I think you got this particular code. The thing is, whenever we are getting the low input to the Arduino from the push button via pin number 9, we are going to send low to the low to the LED via pin number 12. Whenever we receiving the high from the push button to the Arduino via pin number 9, we are going to send the high signal to the LED anode via pin number 12. This is the thing. So let us run this particular code and see what happens. Okay, so see, push button is not pressed, value is equal to 1. Okay, push button is not pressed, value is equal to 1. Then we have to send the, whenever the value is equal to 1, it means push button is not pressed, so that it is an active low with pull up resistor, right? By default we will get the output high, we will get the input high from the push button to the Arduino pin via pin number 9, right? For that reason I am going to send high to the LED anode via pin number 12. Okay, why? Because we are receiving high whenever we not pressing the push button, we are receiving the high. Why? Because it's an active low with pull up resistor configuration. So that I am going to send the high to the LED anode via pin number 12. Okay, let me press this push button and hold it. You have to hold it. Okay, you just need not to, if you press and leave the finger from the switch, then it will again will come into the ideal state. Okay, don't forget about this point about the push button. Okay, I'm going to press and hold the push button. You can see the LEDs getting off. Why? Because we are receiving the input to the Arduino via pin number 9, low input. We are receiving the low input from the push button to the Arduino, so that I am going to send the low output to the anode terminal of LED via pin number 12 of Arduino, so that it makes the LED low. Why? Because I am going to send the 0 volts to the anode, and other terminal cathode is also connected to 0. There is no current will be flowed from anode to cathode. Why? Because both the terminals has the same potential, and to have the flow of current, the anode potential must be greater than the cathode potential. In the previous case, when I didn't press this particular button, so I am going to leave my finger on the mouse pad. You can see over here the LED glows again. This is why, because we are receiving the 5 volts from the push button uh, to the pin number 9, and I'm going to send the 5 volts to the anode of the LED via pin number 12. I'm going to give the 5 volts to the ag I have given 5 volts to the anode terminal of LED, whereas the cathode is getting 0 volts by default because it is connected to the ground terminal. So the anode potential is greater than the cathode potential, and in between we have an 330 ohms resistors to limit the current. So this particular resistance is called as current limiting resistor. Okay, we need to limit the current. Why? Because if we send total 5 volts to the LED, then the LED will be burned burned out in the practical case. Okay, so that reason we have to limit current. For that reason we are going to use 330 ohms resistor. Why we are going to use only 330 ohms resistor is discussed by me in the previous class, in the starting video. You guys watch that particular video. Why? Because it will depends upon the operating voltage of the LED and forward current of the LED. All these parameters I have discussed and derived the uh, resistance of this current limiting resistance. So this is all about this particular video. I hope you got this particular point. So yeah, this is the thing. Instead of watching this particular video, I always recommend you guys to have an hands-on experience after listening this particular video, and also you make this video into a practical session with your own laptops or the mobile phones. You can also do this particular simulations in the mobile phones as well, but there will be some difficulty. You don't have that much of comfortable atmosphere while using the mobile phones rather than using the laptops. So whatever you have, whatever device you have, I always recommend you guys to have an hands-on experience after watching this particular video. You will take in 5 or 10 minutes more time. Yeah, obviously you will you will take more time, um, instead of watching the video while practicing, but you will definitely get an idea, and also you will get in doubts, and also you will get in more clarity about this particular concept. So it's my only suggestion. If you like this video, please like, share and subscribe. Yeah, thank you guys.